Okay, welcome everyone. So before we begin, a quick announcement. So if you are asking questions in your chat during the lecture, so don't send it privately to me or the TA. So you have to post it in the group chat so that uh, like both me and TA need not check two channels. So any questions, don't send it to the TA directly. Like you have to send it only in the public channel. So that's the only thing the TA responsible for the lecture will look at. Okay, so let's start. Let me share my iPad. Okay, so I think just to give you a quick recap, we spent a few lectures on support vector missions, right? Like, and then towards the end, we discussed about the difference between parametric methods and non-parametric methods, where, like to give an example, the primal view of SVM is a parametric method because it has a bunch of parameters. Once you learn these parameters, you throw away the data, right? Like on the other hand, you have this dual view of SVM, like which kind of stores the support vectors. So in some sense, the parameters for the dual view are the examples themselves. So we call it non-parametric because the number of parameters is going to be dependent on the complexity of the data, right? Like another example for non-parametric method was k-nearest neighbors, where you are literally saving every example that you have seen so far, right? Like so, and I think after our discussion on uh, non-parametric methods, we started, like I just introduced decision trees, right? Like so this lecture, like we're going to focus more on the decision tree algorithm. Okay, so this is a bit different from the kind of algorithms that we have seen so far in this course. Okay, so just to give you an example, we have already seen an example last time, right? Like so here is an example decision tree from some data. Okay, so now this data has three features, like uh, whether he has previously like this is a banking, like this is like a prediction system in a bank which decides whether someone is going to cheat, uh, like or default. Maybe I'll just call it as default. Okay, so someone is going to default their loan or not, right? Like so now there are three features here. So one is whether they have previously refunded their previous loans or not, like their marital status and taxable income, right? So now here is one example tree that, let's say, somehow an algorithm has given us. Okay, so now how do I use this tree for classification? So given a new test data where you have refund is equal to no, marital status is married, and taxable income is 80K, so I'm going to start from the root node. Okay, so now it asks whether this person he has owns a home. Okay, okay, I think I kind of copied a wrong tree here. So let's actually add another feature, which is homeowner. Okay, and let's say the answer is no here. Okay, so now I check from the root node. So homeowner, the answer is no, so I go this route. Okay, so then the tree asks me to check the marital status. So the marital status for this particular example is married, right? So you go this way and you find that the answer is no. So the system will make a prediction. No. Is that clear? So this is how we use this decision tree. But then the obvious question that we wanted to answer in the previous lecture is like, how can I learn a decision tree? Given data, how can I come up with this tree structure, right? Like so we actually discussed Hunt's algorithm, right? So which is a very simple strategy where, like, what you would do, okay, so refund is not in the tree because well, it's just a bad example. Like So just consider homeowner, there's no refund. Okay, so the general procedure is like at any node, okay, so at any node, you have some data set, dt. Okay, so we discussed that we need to split the data dt based on some attribute test, right? So for in this example, somehow we started with the homeowner attribute test. So the first thing that we do here is we check if he is a homeowner or not. Okay, that is my first test. Now, based on this test, my data set is going to divide it into two parts, right? Like, so one part of data set where the homeowner feature is yes, and the other part of data set where the homeowner feature is no, right? Now I have two data sets. Now I will continue the same procedure. So let's just to give you, oh, sorry, I wanted to erase. Okay, so just to give you an example, right? Let's say I totally had 100 examples and 40 of them homeowner is yes, 60 of them homeowner is no. Okay, now I have a new data set of 60 examples. I repeat the process again. So I repeat the process and divide it into, let's say, 40 examples and 20 examples. Okay, now I see that if for all the 20 examples the answer is no, you just stop there and say no. But if you still see a mix of yes and no, then you just continue this process. Okay, now that is the general algorithm. Now I have explained the algorithm in a very abstract way, right? Now there is a question which is the crucial question in this algorithm is how to split the rate, right? So who tells me that homeowner is the first feature that I should consider? Why not start with marital status? Or why not start with income, right? And what we are doing here, as we briefly discussed in the previous lecture, is like a kind of greedy strategy. Okay, so we will basically split the records based on an attribute test, okay, that optimizes certain criteria. Okay, so now there are actually many questions to answer before we come up with a solid algorithm. Okay, so the first question is how to specify the attribute test condition. Okay, then how to determine the best split. Let's say I have a bunch of tests. Now how to determine the best split. Okay, then the question of when to stop splitting. Should I keep splitting or when should I stop, right? So I think if we answer these three questions, then we will have like a more solid algorithm that you can actually go ahead and implement. Okay, so let's start with the first question. So the first question is question 1, how to specify the attribute test condition. Okay, so it actually depends on the attribute type. It depends on the attribute types. Okay, so now what are the different attributes types that we could have? So can maybe people type over chat, like, so what kind of attributes or what kind of features like one could have in a data set or in a problem? Okay, so someone says categorical attribute, which means there are a bunch of categories, right? Like, so then can someone give me an example for categorical attributes? So far, okay, male or female, yeah, binary categories. Okay, cat or dog. App fruits is a feature which has apple, orange, bananas. Yeah, so we could have categorical or nominal attributes, okay? We could have ordinal attributes. When I say ordinal, like for example, age, okay? Then you could have continuous attributes. Okay, so now there is also another thing to consider, which is basically the number of ways to split. Okay, so you could either split two-way or you could split multi-way. Okay, let me give you an example. So let's say I have a feature called car type. Okay, now this car type could have multiple types, right? Like, so if I do a multi-way split, then the features would divide into, for example, family car, sports car, luxury car, and so on, right? On the other hand, like if I decide to go with two-way split, then I have to divide only two ways. So now then you need to start thinking about how to group these three things into two ways, right? Like, so for example, one could go for car type is equal to sports and luxury together and family separately, right? Or one could go for car type is equal to sports separately and family and luxury in one side. Okay, so now let's call the first split, right, as A. I'm going to call the second split as B. Okay, so now we are going to do a small poll. So I want you to think about these two types of splitting the car type and tell me which one is the best way to split the car type. Okay, so A or B. I'm launching the poll. So which one of these two car types splitting is the best splitting? Okay, I will stop the poll now. You have few seconds if you want to answer. Okay, I will stop the poll. Okay, majority of you think that first is the best split. Okay, but some of you think that second is the best split. So can someone who think first is the best, like A is the best split, explain why B is not a best split? Someone raise hand maybe. Okay, so there is a answer in the chat which says because sports and luxury are often related. Okay, can someone who said yes for B tell me why is B a good split? Is there any answer? Okay. Random click. Okay, someone who genuinely thought B is the best. Okay, so I think Justin's question is a very valid question. So that is what I wanted everyone to think about. Okay, so how can you say which is the best split if you don't know the data set, or explicitly if you don't know the problem in hand, right? So it really depends on the problem. So let me give you another example. So for example, I want to split size. Okay, size has three values: small, large, medium. Okay, so I could divide this into small, medium, and large. Okay, so maybe I will also give you, okay, first let me give the splits and then I'll tell you what is the problem. Okay, similarly, I could divide this into small, large, and medium in one side. Okay, now which one of them is best, right? Like, so now it really depends on the problem. So for example, let's say I am considering like a way, like let's say my problem requires me to find, okay, so how do I give this example? um Okay, so can someone give me a example task where grouping small with large and differentiating it from medium is better? Any answer? Yeah, so okay, so people are okay, so I forgot my answer, like I forgot my application, but the good thing is like you guys have come up with your own applications. Okay, so risk of accident in a roller coaster, if some small and large needs to be customized but not medium. Yeah, so yeah, so like I think there are a lot of good examples in the chat. Like one example is like depends if you want to look for out of norm size, right? Like so then you might need to put two small, two large things separately and just the normal ones on the other side, right? Like so it really okay. So the main point here is like it really depends on the task in hand. So you cannot decide beforehand which is the best split, right? So in some sense you have to learn which is the best split based on some optimization criteria that we will define shortly. Okay. Now this is for discrete attributes, right? Like so now what if I have continuous attributes? Okay, so let's say I have an attribute taxable income. We have already seen this in the first example, right? Now what is the range of this taxable income? It could go from 0 to all the way, I don't know, millions or billions of dollars, right? So you could earn as much as you want. Okay, so now how can I come up with a tree test? Like how can I come up with a test for continuous attributes? So now there are at least two ways. Okay, so the first way is to actually discretize it so that I move from continuous to categorical. How can I do that? So for example, I could have one node, taxable income, which has multiple divisions less than 10K, 10K to 25K, 25K to 50K, okay, 50K to 80K, and anything greater than 80K. Okay, we could come up with these intervals. Now this becomes a discrete problem. So again, the same question, who is going to give me these intervals, right? Like, so maybe for taxable incomes, there is like a federal brackets for the tax that you could use that federal bracket, like tax brackets, right? Like, so as the intervals. But if you don't have any such guidelines, then you need to come up with a way to find these intervals. Okay. Now there is also another option, which is to come up with a binary decision if you don't want to have multiple outputs, right? Like, so you could have a binary decision, which is basically you have a taxable income and you decide a threshold and say whether this is less than, let's say less than 10K or greater than 10K, for example. Okay, I think the notes has some error. So it says yes and no. It has to be some less than greater than values. Okay, so now again, the same question, like, so how do I determine which one is the best? Okay, so now we have seen examples in discrete case and continuous case. In both the case, the pressing question is, how do I know one split is better than the other split? Okay, so now that is exactly what we will try to answer in the second question. So what was our second question? The second question was how to determine the best split. Okay, so I'll give you an example. Okay, so let's say I have 10 records of some class 1 So class 0 and 10 records of class 1. I have two class problem. Okay, so 10 records of class 0 and 10 records of class 1. So now here is the three features that I'm considering. Okay, so remember that before split, I had C010, C110. Okay, now I could either split it based on gender, in which case this is how the split is going to be, or I could split it based on the car type, and it is going to divide the data set into three parts like this. Okay, so the first part has 1 class 0, 3 class 1. The second part has 8 class 0, no class 1, and so on. Okay, similarly, I could divide it based on the customer ID, and it is going to divide the data set like this. Okay, now here is a question for you. Again, we are going to do a poll. So which one of these splits do you think is the best possible split? Okay, so let's call the first one gender as A, car type as B, customer ID as C. Okay, so I'm going to start the poll. Okay, this time I think it's a rare thing we have all A, B, C options. So okay, I will stop the poll soon. Okay, I'm going to stop. Okay, interesting. So 60% of you think B, so B is the winner. But there is actually a significant percentage of you who think A or B, like C is correct. Okay, so okay, so can someone who clicked yes for customer ID, can you raise your hand? Or maybe you could also post in the chat. So I would like to know the reason why customer ID is a good test condition. Any answers? Definitely 10% of you. Okay, so Dana? Abdul, can you unmute?
I didn't choose C, but I guess what's good about customer ID is that the decision seems easy because you always have 1 0. So like it feels like the leaf is going to be easy.
Okay, so in the case of customer ID, it looks like decision is easy because there is only 1 0 or 0 1. Okay, but here's the issue. So this is for 20 customers, right? Let's say I get a new customer. His customer ID is going to be completely new. It's not one of the old customers, right? So how can I use this tree to classify this new customer? The question is, can I? You cannot, right? Like, so you, yeah. So as someone rightly pointed out, it's kind of overfitting to this customer ID, right? Like, so customer ID is not useful for prediction. It is just a unique ID to put the customer in the database, right? So you cannot use this for new customer. Okay, so this is actually bad thing. Okay, so now we have A versus B. B is still the majority, but can someone who said A is the best possible split tell me why A is the best possible split? Why is gender the best possible split? You could either raise hand or answer in the chat. Any answer? Okay, so there are answers saying it's well-balanced number of customers in both. I think both the answers say the same. Okay, now is that a good thing or a bad thing? So it's kind of true that in the case of gender, it is almost 50-50 split. each split has 6-4 or 4-6. It's a good thing or a bad thing? It's a bad thing, right? Like as people point out in chat, it is a bad thing. So this is bad. Why? Because I don't gain anything by doing this split. I still have the confusion of whether it is class 1 or class 0. Okay. So this is also a bad thing. Now, on the other hand, if you consider car type, it is being more discriminative because you can see that when the car is sports car, it is 100% class 0. When the car is luxury, it's almost 100% class 1, right? Like similarly for family car, it's almost as in three-fourth of the time class 1, right? So this seems to be a more discriminative feature. Okay, so now the main lesson from this whole discussion is we generally prefer nodes with homogeneous class distribution. Okay. Now, in this case, this is 100% homogeneous, right? Like the sports section, because it's all class 0. On the other hand, this is bad. The gender thing is bad because it's not at all homogeneous. It's like equal mix of two things. Okay. So what we really need to automate this process is a measure of node impurity. Okay. So we want a measure or metric which will tell that this particular node is pure and it is preferred. Okay, I'll give you an example. So there could be one split which gives you 5 class 0 and 5 class 1. There could be another split which gives you 9 class 0 and 1 class 1. Okay, now this is an example of a non-homogeneous node. On the other hand, this is homogeneous node. Okay, so this has high degree of impurity. Okay, on the other hand, this has low degree of impurity. Okay, so now how do I measure node impurity? So there are many ways to do this. Okay, in this lecture, we are only going to discuss 3 most popular ways. So which are Gini index, entropy, and misclassification error. Okay, so now even before I explain what is Gini index or entropy or misclassification, I'm going to tell you the general procedure to apply them. Okay, so the general procedure is this. So usually before splitting, I would have some number of class 0 and some number of class 1. Okay, I can compute this measure. Let's call it P. This tells how pure is this node. Okay, now I have 2 options to split. I could split based on A, some feature A or some feature B. If I split based on some feature A, then I will get these 2 data sets, and these 2 data sets are going to have some measure. I could take an average of that. Okay. Similarly, if I go by B, I will get these 2 splits, and these 2 splits have these 2 measures, and I have some average. Okay. Now the gain by splitting based on A is given by P minus M1. Similarly, the gain by splitting with B is given by P minus M2. Now, if P minus M1 is greater than P minus M2, then it means I have more gain by splitting with A. So then you basically choose split A. Okay. Now, this is the general idea. Is there any questions? Any questions, chat, or raise your hands before we start seeing the metrics? Okay, what does P represent exactly? So that is what we are going to discuss next. So this is just a abstract figure to explain what we are going to do. Okay, so can you please repeat what is M? Okay, so maybe, okay. I think all these questions will be clear, like if we just see one example for this, okay? So, okay, so what exactly mean before splitting? Before splitting means like before you consider doing any split. Okay, I think all these examples will be clear if we actually see an example. So let's do a running example. Okay, so we are going to consider Gini index. Okay, so now Gini index of a node T is given as Gini of T, which is equivalent to 1 minus summation over J probability of J given T. Okay, where P of J given T is the relative frequency of class J at node T. Okay, so let me, now this is the formula. Okay, it will be much easier if we do some examples. So let's do some examples. So the first example is I have C1, 0 class 1 and 6 class 2. Okay, now what is the probability of C1? It's 0 by 6. What is the probability of C2? It's 1, 6 by 6, 1, right? So now my Gini is given as 1 minus 0 square minus 1 square. So 0. So this has 0 Gini. Okay, now let's say I have C1 is equal to 1, C2 is equal to 5. Now what is probability of C1? It's 1 over 6. Probability of C2 is 5 over 6, right? Now my Gini is given us 1 minus 1 over 6 the whole square minus 5 over 6 the whole square. Okay, so I'm not going to do it here. Like, so the answer is 0.278. Okay, so now just to give you one more example so that you understand the range. So let's say I have equal split 3 and 3. Okay, so now if I do Gini, I'm going to do it directly because we have done this a couple of times. 1 minus 1 by 2 square, the probability of C1 square, minus 1 by 2 square, the probability of C2 square. Okay, now this is exactly 0.5. Okay, I think now this will answer a lot of your questions. Okay, so now what is the range of Gini? Can someone tell me what would be the range of Gini for a 2-class problem? 0 to 1, is that true? How can you get 1 Gini? Yes, it's 0 to 0.5, right? Like, because you already have the range here, because this is one extreme. One extreme is everything in from one class, right? Like, so it has a value of 0. The other extreme is equal distribution, right? So the value is actually between 0 to 0.5. Okay, is that clear? So the range of Gini is between 0 and 0.5. Okay, okay. Remember, this is for 2-class problem. If I have to generalize it for multiple, like like K-class problem, okay. So Gini is given by 1 minus 1 over NC, where NC is the number of classes. Okay, so this is the maximum value. The minimum value is always 0. Is that clear? Any questions? Okay, then there was another question in the chat, which was basically, how do I, okay, so now this tells you an idea of, okay, let me erase all these things so that we can discuss more on this graph picture again. Okay, So, okay, I have a small eraser. Okay, so now we know how to compute P, right? P is basically the Guinea for this table. M11 is the Guinea for this table. M12 is the Guinea for this table. M21 is the Guinea for this table. M22 is the Guinea for this table. That we know how to compute now, right? Now the next question is, how do I come up with M1 and M2? How do I combine these two Guineas together, right? So the way in which we are going to do that is like this. When a node P is split into K partitions, okay, then the quality of split is given as Guinea split, okay, is equal to summation over I is equal to 1 to K Ni by N Guinea of I, okay, where Ni is equal to number of records at child I, and N is the total number of records. Is that clear? So all you will do, like for example, in this case, M1 is given by the frequency of data in the first table multiplied by M11, right? So M1 is equal to some frequency 1 multiplied by M11 plus some frequency 2 multiplied by M12. Is that clear? Any questions? Okay, so now let's see an example for this. So here is an example, like where initially this, okay, well, is a different color. This is my parent node. It has 7 class 1 and 5 class 2, and the Guinea is given by 0.486. It's close to 0.5, right? Like because it's 50-50. Now I have condition B, which splits data into two sides. Okay, so now you can see that this is my first Guinea, which is computed here, and this is my second Guinea, which is computed here. Okay, and the weighted Guinea is given by this formula. Okay, so initially before split, I had a Guinea of 0.486. Okay, now after split, I have a Guinea of 0.361. So ideally, we want the Guinea to go down as we do more splits, right? Like we want the Guinea to go close to 0, right? So now the gain from here to here, based on the split, the gain is given by 0.486 minus 0.361, which is already written here, which is 0.125. Is that clear? So it's important that you understand how to do this. Like once you know this, then you could apply this for all the previous issues like categorical, continuous, and so on. Okay. Okay. So now that we know how to do Guinea, so now we can go back to our previous problem, right? Like, so whether I should go for a multi-way split or a two-way split. Now you don't need to think about this subjectively because you have the metric, right? Like, so you want something which achieves low Guinea, right? So now if you do multi-way split, this is the Guinea. If you do two-way split, there are two possibilities. So the first two-way has this and the second two-way has this. Okay. So now there were a lot of you who thought that sports and luxury should go together, right? But you can see that based on this data set, for some data set that we have, putting sports and luxury together has a higher Gini index. Okay. On the other hand, this has better. And it so happens that this is the best. So if you want to answer the question of whether to go for two-way split or multi-way split, just compute the Gini, whatever has the lowest Gini, go for it. Is that clear? Okay. So now how do we do this for continuous attributes? So that is a bit tricky. Okay. So we discussed in detail about discrete attributes. So now let's go back to continuous attributes. Okay. So how do I do this for continuous attributes. Any idea? How can I do Guinea? How can I compute? How can I use Guinea and find the best value for continuous attributes? Maybe like I would appreciate if someone raises their hand and give me a solution. Okay, so there is a chat which says use greater than less than to discrete, but then the question is, how would you do that? Give me the algorithm, right? So I think that the suggestion here is try different values of V to have A less than V and A greater than or equal to V. Okay. Now this is a very like a simple solution for this. This is a simple solution. Okay. Now this is actually very inefficient. Why? Because it's a real number, right? Like, so you cannot consider every possible value and count less than, greater than, and compute Guinea, right? Like, so you're going to do this for thousands of possible splits, right? Like, so is there a smarter way to do this? Okay, so is there a smarter way to do this? So it so happens that we can actually do this in a much smarter way. So the smarter solution is explained here. So what you can do is actually sort the values. Okay, you see the sorted values, right? Now you sort the values and consider splits between these sorted values. So instead of considering every possible number, you could consider, okay, what if I choose 55? What if I choose 65, which is in between 60 and 70? What if I choose 72, which is in between 70 and 75? Okay, so now you can easily compute Guinea. You could do some smart computations to reuse your computation, and you actually find that the lowest Guinea possible is given for V is equal to 97K. So the data, the best split is annual income less than 97K and greater than or equal to 97K. Is that clear? Okay, so now we looked at one splitting criteria, which is Guinea, right? Now there are actually many other criteria available. Okay, maybe before I move to that, so this Gini criteria is used in decision tree algorithms like CART or SLIC or Sprint. Okay, so there are hundreds of variants of decision tree algorithms. So the goal of this lecture is actually to introduce you the idea of decision trees, not an individual algorithm. So we are not going to see an individual algorithms like, but you could actually go explore different algorithms in sklearn by yourself. Okay, but we will move to the second splitting criteria, which is entropy. Okay, so what is entropy? We know the definition of entropy, right? So entropy is given by minus summation over j, p of j given t, log p of j given t. Ideally, it measures the homogeneity of the node. Okay, so now let's do some examples again. Okay, so I'm going to consider the first example, which is a pure example. Now, what is entropy? Entropy for this is given by minus the probability of the class 1, 0, minus 0 log 0, minus 1 log 1. Okay, so log 0 is undefined, but just for this algorithm, like we're going to consider that to be 0. So the whole thing becomes 0. So when you have a pure split, entropy is 0. Okay, let's look at another example. C1 is 1, C2 is 5. Now, how would you compute entropy? Entropy is minus 1 over 6 log 1 over 6. This is for the first class. For the second class, it's minus 1 over 5 over 6 log 5 over 6. Now, value, you could use your calculator. The answer is 0.65. Okay. Now, the same question. So what is the range of entropy? Can someone guess the range of entropy? So in one hand, you would have pure split, and in the other hand, you have equal distribution, right? So what is the range? Well, it is not arbitrary. So what is the entropy for pure split? We have already seen it. It's 0, right? Now, what is the entropy for equal split?
Hello?
Yeah?
Yes, actually, I have a question regarding the previous slide. Just what I
Yeah.
was saying, just arbitrary. I'm talking about
Okay.
the split position. In your
Okay, okay, okay.
slide, you saw 55, 75. Why not start by
Oh, yeah.
75 and
So that is,
100?
okay, that is arbitrary because there is nothing in between.
Okay, so this is just arbitrary.
Yeah, but you could also go with the mean of the two values if you want.
Okay, okay, thank you.
Okay, so now what is the maximum entropy? So is it 1? Is it exactly 1? So let's take a 2-class problem, right? Like in 2-class problem, it's going to be minus 1 over 2 log 1 over 2 minus 1 over 2 log 1 over 2. So it's going to be minus log 1 over 2. So it's going to be log 2, right? So if you want to generalize this, the maximum value is log NC, where n is the number of examples. Is that clear? Now, similarly, like just like how we had gain for Guinea, we could also have gain for information here. So the info gain is given as entropy of my node P minus summation over I is equal to 1 to n ni by n entropy of the individual child. Okay, so now I told you that Guinea is used by algorithms like CART, Slick, and Sprint. So entropy is actually used by algorithms like ID3, which is one of the most famous, C4 4.5, which are actually two of the most famous algorithms, like decision tree algorithms. Okay, so similarly, there is a third class criteria. I'm not going to touch it in detail. Like we will just mention it, which is basically the classification error. Okay, so what is classification error? The error of t is given by 1 minus max over p of I comma t, I given t. Okay, so now this basically means that I don't have an example in the notes, but maybe let's do an example. So for example, let's say I have class 0 to be 0, class 1 to be 1. Okay, now my error is given as 1 minus max of 0 comma 1, right? Like probability of the first one is 0, probability of second is 1. So it's going to be 1 minus 1 is equal to 0, right? So what is error? The error basically means that if you have two classes, whichever is the majority class, you assume that is the true class, and you just compute error to be the rest of the classes, right? Like, so to give you another example, so let's say C1 is 5 and C2 is 5. What would be the error here? It's going to be 1 minus max over the probability for the first class is 1 by 2, second class is 1 by 2. So it's 50% error, right? So it's 1 minus 1 by 2, which is equal to 1 by 2. Okay, now what's the range of this? So the minimum is always 0, right? Maximum is given by 1 minus 1 over NC. Okay, so now here is a comparison of all the three splitting criteria that we have seen. Okay, so you can see that whenever the fraction is completely 0 or completely 1, you have 0 value. And they all achieve maximum in different places. Like, so both Gini and misclassification, the maximum is achieved as 0.5. For entropy, for 2-class setting, it is at 1, but for n-class setting, it's going to be different. Is that clear? Okay, so I think I will stop here for a short break. So we will see again in 10 minutes. I'm going to stop the recording.